Be honest, it's probably been at least about 12 years since I used ARP main studs. Did I make a critical error? Let's take this thing back out and find out.
Built with soul, not just steel.
Okay, so we have all the bearings out. What we're gonna do is, according to ARP, a line hone might be needed due to the different clamping force. Now, we are running slightly oversized bearings, which gives us a little bit more room. But we wanna make sure these are true and not oblong, because when they clamp, they can change the shape. So what we're gonna do is we're gonna use a T-mic. We're gonna T-mic each one of these journals from different angles, and I'll throw up the specifications on here, but I believe it's 8 thousandths is the allowable clearance. Anything above that has to be line honed. So we're gonna run this through real quick just to verify, and we gotta get these torqued down back to the 60 foot-pounds. So we'll go ahead and get all these nuts and bolts back on. We backed out all of our Allen bolts. And we're gonna actually leave them backed out about a half turn. They're all about a half turn out right now. We'll leave that, we'll torque it down to 60 foot-pounds, and then, like I said, we'll run the T-meter through. Something about these blocks in particular, this is the 1uz non-VVTi. I'm sure it's the same on the others, but right here stamped in the block itself, it'll give you from front to rear the bearing specification, sorry, the journal specifications. There's a spec for size 3, a spec for size 1, spec for size 5. So let's get this torqued down and then we'll move on. So we're gonna take this T-gauge here. What we're gonna do, as you guys look down here, we're gonna take multiple measurements. We're gonna cut it into a pie, and we're gonna check our measurements and make sure our measurements are all within that 0.008. Again, we'll have to get the measurements off the side of the block for each one of these. I know the first journal diameter for main bearings Mark III is supposed to be 66.9968. So 66.9968, and that's going to be number 3. And we got a number 4 and a number 5 on here as well. Number 4 and number 5. Number 4 should be 66.9960. 66.9960. And number 5, right below that, 669950. 66.9950. So if any of our measurements are out, we'll know that this thing needs to be line honed. If they're out within 0.008 of each other. So say we have 66.968 across, but we have 66.95 something here, then we know that, okay, this one's out around that type of thing. Okay. All right. So this is the tedious, time-consuming part. So I'm going to show you how to do one, and then I'll get the rest, and then we'll let you know what we find, and then see if this thing's got to go to the machine shop to be line honed or not. And we'll start with the first one. We're going to do our vertical measurement first. Nice thing about these T-gauges, they go in, they're spring-loaded, so you can line them up. Because this is a circle and this is a straight edge and it's spring-loaded, you just got to be close to perfectly vertical. Then you lock the end down here. Okay, let's mic this out and see where we're at. Okay, according to my paperwork, this is cylinder. It doesn't go 1, 2, 3, 4, 5. It goes 1, 2, 3, 4, 5. So cylinder 1 is bearing, or is measurement 3. Cylinder 2 is measurement 4. Main bearing journal. Number 3 is 3. Number 4 is 3, and number 5 is 5. So this measurement here is with the bearings installed. I just realized that. So what we're going to do, because we know that the difference is 0.008, that is our maximum difference in the journals. I'm going to go ahead and measure this with the bearings out of it, and just look for anything greater than this in the overall shape. So according to ARP, these can change the spherical shape and make them oblong. So as long as all of these are within this amount of each other at all these angles, we can move forward with it. So I'd feel comfortable. Again, if I was building this for someone else, that would be a different story. If being that this is my motor and it's a drift motor and the crank is forged, worst case scenario, it eats up some bearings. We'll take it back apart. Super easy to pull in and out of the Celica, and we can yank it back apart and take it to the actual machine shop. But if everything measures out within that 0.008, I'm going to feel comfortable with putting this thing back together in my own personal vehicle. So let's go ahead and get these measurements done. Again, we're going to take a T-gauge. I already have this one preset for the vertical on bearing number 1. So we're going to take our micrometer, make sure it's set to true 0. Zero this out. There's 71.92 on our first angle. Now we're going to go across. Nice thing is you loosen these here, and then these spring loads back out. Then you can place it in your bore here. We're just going to go right above and right below, so from the top bearing to the cylinder block surface. Okay. Okay. We have 71.93, which is 1/100th larger. We can only vary by 8 thousandths. So we're gonna call it there. We're gonna yank these cylinder heads off. We got a lot of work to do still. We'll probably end up pulling the pistons on here. I'm glad we checked. I'm glad everyone on the internet caught me slipping. Again, it's been about 12 years since I did ARP studs. I totally forgot about line honing. The bearings, even from spinning by hand, the crank felt great. This was originally a studded motor anyway. The 1uz comes pre-studded, but the clamping force from these studs to the factory studs are different. So definitely want to run a line hone through here just to be safe, since we know it is off. It feels great, but again, it's an optical illusion. I mean, we're talking thousandths. So minimum was 0.008. We're at literally 0.010. That is, I mean, 2 thousandths above its specs on one journal. So I'm not even going to test the rest of the journals. So if you guys are watching this, my mistake. Again, we're going to just get it done. Since it's already torn apart, we can just drop it off at the machine shop. Hopefully they won't take too long on it. We're kind of in a small town. We have one machine shop, and hopefully they go a little fast with the process. So we're going to leave the bolts torqued, and then we'll have them line honed. And I may end up just having them surface the block and heads for me. I was going to clean it up myself, but being that it's going to be there, it might just be easier to have him do it. So thanks for watching this episode, guys. That was, you show that we're not all perfect and we all make mistakes. This would have been, I think it would have been at 2 thousandths, probably would have lasted a while. But since we're already here, best just to get it done. You know, the bearings look fine. So I don't think they're destroyed. We'll plastic gauge them when we go back together with this thing. But this will put a pause on moving forward with the Celica project. But we do have the Willys custom V6 swap videos coming soon. So those videos will be coming up. We'll put a pause on the Celica videos till we get this back from the machine shop. Until then, you guys, this is JP Street and Performance, where dream cars are built, not bought. From the first cut to the final pass. I'll catch you on the next project.